In January 2005, NASA launched a strange and fascinating probe into space. Its mission was to answer one of humanity's biggest mysteries. Where did the water on Earth come from? This probe, named Deep Impact, traveled an incredible 270 million kilometers before finally reaching a comet. Hidden inside this comet were secrets that scientists had been searching for over centuries. Welcome back, viewers, to another amazing episode. Out of the entire universe, there's only one place where human beings can truly live: Earth. It almost feels like this planet was specially designed for us. Here, we have everything that life needs to survive: water, food, and oxygen. In this vast and gigantic universe, there may or may not be another planet like Earth, but for now, it's the only one we know where humans can live without any help. But here's the crazy part. 5 billion years ago, Earth didn't even exist. The space where our planet and solar system now float was once just the edge of the Milky Way galaxy. Back then, instead of planets, there was a gigantic cloud made up of dust and gases. This strange massive cloud was called a molecular cloud. It was filled with dust particles, tiny grains of sand, silicon, and different metals. The birth of this cloud came from the death of old stars. In the early days of the universe, stars that had burned all their fuel exploded, and the particles from those explosions spread across the cosmos. Now, this wasn't a fluffy white cloud like we see in the sky. It looked very different. The Hubble Space Telescope has captured images of such clouds, and they're truly breathtaking. Believe it or not, this cloud was about 100 light-years wide. That means if light started traveling from one edge to the other, it would take 100 years to cross it. To make it simpler, imagine the distance between the Sun and Earth. Now multiply that by 6 million. That's how enormous this dust cloud was. It's inside clouds like these that new stars and planets are born. The power behind this creation is gravity. Yes, the same invisible force that pulls things toward each other. Gravity doesn't actually exist in space. It's generated by the mass of objects. The bigger an object, the stronger its gravitational pull. Inside this molecular cloud, particles began to attract each other because of gravity. Larger particles started pulling in the smaller ones, and soon they began colliding and merging at incredible speed. These constant collisions created energy, heating up the spinning cloud's core. Over millions of years, this process continued. The core grew larger, spun faster, and became hotter. Eventually, it turned into a gigantic fiery ball: our Sun. The leftover molecular cloud began to spin around the Sun, and from its remaining particles and gases, planets, moons, and even life itself would eventually form. But how exactly did that happen? For centuries, this remained one of the biggest mysteries in science. The first people to come up with a theory were German philosopher Immanuel Kant and French scholar Pierre-Simon Laplace in the 1700s. They proposed that stars, like our Sun, could form from collapsing clouds of dust and gas. At that time, it was only an idea. Later, between the 1920s and 1950s, telescopes became more advanced, but astronomers still couldn't observe inside these clouds. Then came the inventions of radio and infrared telescopes during the 1970s and 1980s. These made it possible to see through the dusty clouds. Scientists finally observed new stars being born inside molecular clouds. This confirmed that stars really do form within them, and from the leftover dust, planets are born. But there was still one big question. How does this process actually start? Many theories were proposed, but finally, in March 2003, an experiment aboard the International Space Station gave us the answer. Astronaut Don Pettit conducted several experiments to study how materials behave in space. He created water bubbles, dissolved rings, and spun a plastic bag filled with salt to see how it would react. Although the goal was something else entirely, the final experiment unexpectedly solved an age-old mystery. When Pettit placed salt in the plastic bag and spun it, the salt particles began sticking together. In space, tiny particles naturally attract each other. Scientists realized that inside molecular clouds, Dust particles orbiting the Sun in the same direction must have behaved the same way, clumping together like those salt grains. And that's how, around 4.5 billion years ago, the very first building blocks of planets began forming, tiny particles coming together in space, just like Don Pettit's salt experiment. In Don Petit's experiment, the salt particles began sticking together in space. As this growing cluster reached the size of a mountain, nearly a kilometer wide, its own gravity became strong enough to pull in even more particles around it. It worked just like a giant vacuum cleaner sucking up dust. For the next 3 million years, this process continued. Gradually, around 20 young planets began to form, all orbiting the Sun. But since these planets were growing massive, their gravity started pulling each other closer as they orbited. Eventually, they began to collide. Each collision between two planets merged them into a bigger one. Over time, this series of cosmic crashes reduced the number of planets from 20 down to just a few, the ones we know today: Mercury, Venus, Mars, and our Earth. But back then, Earth wasn't the calm blue, life-filled planet we know. It was a blazing fireball, burning intensely from constant impacts. If any living organism had existed then, it would have evaporated in less than a second. Life could only appear once Earth cooled down. But before that, it had to survive its biggest threat, the solar storms. Yes, the same powerful storms that erupt from the Sun's surface and send deadly radiation out into space. When these solar winds strike a planet, they can destroy its atmosphere. That's why many planets, including Mars, can't support life. Solar storms stripped away their air and protection long ago. So, how did Earth survive these deadly storms? The secret lies deep inside our planet, in its core. When Earth began forming within the molecular cloud, its temperature soared. Rocks melted, and heavy metals like iron and nickel sank to the planet's center. Geophysicists believe that when molten iron spins, it creates a magnetic field. Since Earth's core contains a massive amount of molten iron, it continuously generates this field. In space, this region of magnetic influence is called the magnetosphere. On the side of Earth facing the Sun, the magnetosphere extends about 370,000 kilometers, nearly the same distance as the Moon. On the opposite side, it stretches millions of kilometers farther. This magnetic field acts like an invisible shield, blocking most of the Sun's harmful radiation. At the North and South poles, however, the magnetic field is weaker. So some solar particles slip through the atmosphere and collide with air molecules, creating glowing waves of light known as the aurora borealis and aurora australis, the northern and southern lights. Luckily, this radiation is far too weak to harm life. Earth had successfully survived the solar storms, but it was still far from ready for life. It now faced an even more dramatic challenge: a planetary collision. How do we even know about this ancient cosmic crash? For that, we need to go back to the 1960s, when the United States launched several Apollo missions and sent astronauts to the Moon for research. At first, scientists believed the Moon was simply a chunk of Earth that had broken off somehow. But when astronauts brought back lunar rock samples, scientists noticed something strange. These rocks didn't look like those found on Earth. They appeared as if they had been burned. Further investigations revealed that the Moon and Earth rocks had identical oxygen isotopes, proving that the Moon was indeed part of Earth, but had once been superheated. What could have caused that? Only one thing: a massive planetary collision. When Earth was slowly cooling, a Mars-sized planet began drifting toward it. This planet was later named Theia. When Theia smashed into Earth, the impact released unimaginable energy. Molten fragments from both planets exploded into space and began orbiting Earth. Over thousands of years, these fiery fragments merged, just like the particles in the molecular cloud, and formed what we now know as the Moon. In the beginning, the Moon was much closer to Earth. Experts say it appeared about 15 times larger in the sky than it does today. But over time, It's been drifting away at a slow but steady rate of 1.5 inches per year. The collision between Theia and Earth and the creation of the Moon were two of the most crucial events in cosmic history. Scientists believe that if these two moments had never happened, life might never have existed on Earth. Because when Theia hit Earth, it did more than just form the Moon. It also tilted Earth on its axis. That massive collision tilted the Earth, which had once been spinning straight on its axis. Now it leaned at an angle of 23.5 degrees, and that small tilt changed everything. Because of it, our planet got something truly magical: seasons. As you probably know, one full spin of Earth makes a day, and one full trip around the Sun makes a year. But since Earth is tilted, the months when the northern hemisphere faces the Sun are hot. That's summer. And when it tilts away, it becomes winter. This tilt means our planet never experiences constant heat or cold all year round. These changing seasons bless us with different fruits, vegetables, and the beauty of shifting colors throughout the year. Thanks to the monsoon cycle, we get rainfall that fills our rivers with clean, drinkable water, and the Moon, formed from that great cosmic collision, plays its own crucial role. It creates ocean tides which stir up nutrients vital for marine life. Without these tides, nutrients would remain trapped in a few small areas, making the oceans lifeless. But wait, all of this works only if there's water on Earth. And that raises one of science's biggest mysteries. Where did all the water come from? To find the answer, NASA launched a special probe called Deep Impact in January 2005. It was sent on a 270 million kilometer journey to a comet named Tempel 1. Attached to the probe was a 350 kilogram copper impactor, designed to smash into the comet's surface on July 4, 2005. The impactor struck Tempel 1 at a mind-blowing speed of 38,000 kilometers per hour, creating a massive crater. Using powerful radio telescopes aboard Deep Impact, scientists recorded this collision, and what they discovered was absolutely stunning. When they analyzed the light from the explosion using spectroscopy, they found that Tempel 1 contained frozen water, actual ice deep inside the comet. This proved that comets far away in the asteroid belt carry huge amounts of water, but the real question was, how did those comets travel all the way to Earth? And not just one or two, but millions of them over time. Experts believe only one planet could have done that: Jupiter. Jupiter, the largest planet in our solar system, has gravity so powerful that it can alter the orbits of asteroids and comets nearby. It orbits right next to the asteroid belt, and its immense gravitational pull distorted their circular orbits, stretching them into elliptical, oval-shaped orbits. Because of this, many comets were flung toward Earth's path, and gravity pulled them in. Scientists now believe that Earth didn't originally have any water at all. Instead, comets delivered it around 500 million years after our planet's formation. But how do we know that? The answer lies in a special mineral called zircon. Zircon forms only when water is present, and it contains traces of uranium which slowly decays over time. By studying that decay, scientists can determine zircon's exact age. When researchers dated zircon samples from Earth's oldest rocks, they found they were about 4 billion years old, meaning they formed roughly 500 million years after Earth was born. So, let's piece it together. Earth formed from the molecular cloud. Then came the Mars-sized planet Theia, which collided with Earth. That impact tilted our planet, created the Moon, and gave us tides. Then, from millions of kilometers away, Jupiter's gravity helped send icy comets toward Earth, bringing the precious water that made life possible. By now, Earth's temperature had cooled to around 100 degrees, but it still lacked one final ingredient for life: oxygen. So tell me, what do you think? How did oxygen first appear in Earth's atmosphere? Share your thoughts in the comments, and don't forget to like and share this amazing story. Thank you all for your love and support. See you soon in another spectacular Information for All video.